Sige, let's ano. Wait lang sandali. Sandali lang class ah. Okay, so okay naman yung ano ko. Okay naman yung audio ko. So, sandali na lang. May nag-chat lang kasi. Okay, so um, pasensya na kayo last week. Hindi tayo nakapag-meet. Okay, pero we'll try to make it up ngayon. May mga susunod na mga linggo. Okay, so basically, we will continue with our discussion with with this topic. So we will now go to what we call system modeling. Okay. So, pero bago ko puntahan yan, I would like to come back here first. Okay. With a discussion on what do we what would be what would be try to to study and what would we try to achieve in this course. Okay. So basically, pag-uusapan natin itong tatlong ito. Okay, yung tatlong yan. Okay. Pero bago yan, pag-ibahin muna natin yung tinatawag na analysis at saka design. Okay. So analysis is the process by which a system performance is determined. Okay. So that is when you say system performance, it means that we will characterize. Okay. For example, if you have a certain system, i-describe muna natin kung ano. We will try to describe how is the system performing currently as it is. For example, if meron kayong elevator, okay, if you have an elevator, um, how fast is the elevator responding to a certain command? Okay? Gaano kabilis siya nakakapunta from, for example, first floor to fourth floor? Okay? Masyado ba siyang mabilis? Okay? O kaya, sa una ba mabagal siya? And then pagdating sa gitna, bibilis siya, and then bigla siya mabagal? Okay? Or, pagdating sa taas, pagdating niya sa fourth floor, o pagdating sa destination niya, may mararamdaman kayong konting shaking. Okay, merong konting up and down oscillation yung elevator niyo before it actually comes to stop. So that's characterization. Okay. Now, what would we characterize? Okay. Or how would we characterize? Or in what way would we characterize your system? Okay. Number one, in terms of transient response. Okay. So, transient response means how your system is reacting to a certain input. Okay? It can be too slow, it can be too fast, or it can oscillate for some time. Okay? So that is that is what transient response means. Okay? So yung part ng response niyo in which your system is ought to react to a certain input. Okay, that is the transient response. Okay, so gaano ba kabilis yan? Maaaring masyado siyang mabilis. Okay, o kaya masyado siyang mabagal. Okay, and so on. So that is transient response. O kaya baka maaaring sumusobra siya dun sa input command nyo. Okay, and so on. Okay, that's transient response. Now, there will come a time that your system would actually become settled, okay, in his input and in his output, and that the form of the output would be the same as your input. Okay, so in that case, pagka nasa tinatawag nating settling part na yung system niyo, when your system is said to be in its steady state, okay, when it is said to be in its steady state, okay, what we would like to know is how accurate your system is. Gaano ba siya ka-accurate dun sa command niyo? Okay, your command, okay, your input command is this, but your system may be just have an output that is something like this one. So, ano siya, there is a gap between your command, your reference input, and your actual output. Okay, so that gap is what we call the system error. So that's another thing that we will have to characterize your system in terms of system error or steady state error. That's another term that we can use to describe that gap. Okay, steady state error. Yeah. Okay, so we will characterize also your system in terms of that. Okay. Another thing, okay, here's the thing. These two, okay, can be measured directly. When you have a graph or when you have a response curve, such as this one, okay, when you have a response curve that looks something like this, that is shown, okay, you can directly measure the transient response parameters, the transient response characteristics, and the steady state error using this response curve. Okay, but what is something that is not really obvious here, or that is not indicated here, but can actually be deduced from how your graph or from how your response curve looks like, is yung stability. Okay, now later on we would have some various definitions of what stability is. So we will be defining stability in various ways. Okay? Pero ang natandaan natin is that, number one, stability is the most important requirement or is the most important characteristic of your system. Okay? Mainly because if your system is not stable, your system is, number one, unsafe to use, and number two, cannot be used altogether. Okay? Um, that would involve, for example, that would involve your system to be, say for example, um, going runaway. Halimbawa kung yan ang elevator, eh hindi lang siya basta mapupunta sa 4th floor. Lalagpas pa yan. Kahit na i-command mo sa 4th floor, lalagpas yan ng 4th floor kung saan siya mapupunta. Or it would include, say for example, your rockets to be exploding and not going to the position that you would like it to go. Okay? Or something like those. Pag yung system mo ay hindi stable. Okay? So, an unstable system is unusable, okay, and unsafe to use. That's one thing that we have to remember. So that is why it is really important that we characterize our system to be stable. Anyway, ang characterization naman ng stability or ng system niyo in terms of stability is that either your system is stable, not stable, or marginally stable. Yun lang naman, sabihin nyo na naman, stable ba siya, hindi ba siya stable, or marginally stable siya. Okay? But the thing is, this is something that is not really obvious in a response graph, something like this one. Although in this case, we can say that your system is stable. In this case, in this particular case that we are showing on the board, okay, we can say that your system is stable. Okay, mainly because we see that the steady state response, okay, has the same form as that of the input command. So yung input command nyo is basically a constant. So your steady state response also is a constant. So kapag pareho yung input command nyo at saka yung steady state response nyo, then you can say that your system is stable. So that's one way we can actually define stability. Yung pagkapareho, yung form ng input command niyo at saka ng steady state response niyo. Okay? Is that understood? Okay. So, that. Ngayon, what I would like to point out is that if your system is not stable, okay, these other two things are not measurable. You will not be able to measure these other two things, okay, if your system is not stable. That is why stability is the most important parameter of your system. Now, after characterizing your system, and nakuha nyo na yung characteristics na to, you were able to determine these characteristics. Okay. You might be not satisfied. Your instinct or your requirements for your system say that the performance exhibited by your system is not enough. Okay. So that is the time that we go to design of your system. So, meron kayong system, tingnan nyo yung proseso. Meron kayong system, okay, you were able to determine, okay, number one, that your system is stable. So, you were able to measure the transient response and system error. Okay. And then from there, you say na, masyado mabagal yung system ko. My system is too slow for my requirements. So, the requirements is that it should be this fast. Okay. And that the error should be this small. Okay. So, take note, ang una kong sinabi is that you were able to determine that your system is stable so that you are able to measure the other two or the other two things or the other two performance indicators. Okay? So you were able to say that your system is too slow and it has too much error. Okay? Now, from there, you need to now proceed to the design. Okay? Doon tayo pupunta ngayon sa design. In that case, you would say that I would want my system to be this fast. And I would want my system to have this very small error. But at the same time, I would like the system to be stable. Okay, so as I try to achieve the other two objectives, okay, I would like my system to be stable. So ito yung ito yung sinasabi natin dito. The major objectives and design. Major objectives of system design. Okay? That is, you would like first to have a desired transient response. You would like your system error or your steady state error to be reduced as small as possible. And in all of this, you would like your system to be stable. So these are the three major objectives of designing your system. Okay, is that clear? Okay. Now, so please lower your hands. Okay, so now in that process, okay, we now have basically 6 steps. Okay, we basically have these 6 steps in order for us to come up with a design. Okay, keeping in mind yung those three keeping in mind those three objectives that is required, okay, of you, okay, when designing system. Okay, so step 1 is to determine the physical system and specifications from the requirements. So basically, you now have a physical system. Siyempre, meron, pag magde-design ka ng system, meron ka dapat na physical system. Okay? And you would now want to know what are your requirements. So the requirements would include, say for example, your system to be this fast. Okay? Or your error should be this small. Yun yung mga requirements na ibibigay sa inyo. Aside from, for example, cost requirements or something like the system should work for around 15 to 20 years. Mga ganun, kasama yun sa mga requirements that can be given of you. Okay. And then your objective is to actually work on the system within those requirements. Okay. Now after this, but you would be able to do that, okay, after you actually go through. Kasi basically, that requirements would be met somewhere between step 2 hanggang step 6. Okay? If you are, you would be able to determine if you are meeting the requirements. Actually, on the step 6 na. Ma-determine mo na kung na-meet mo na siya. Pero, to ensure that you meet those requirements, it would be in between this step 2 hanggang step 6. Okay? Now, after you are able to have your physical system, you now have to draw a functional block diagram. Okay? The functional block diagram would look something like this. Okay? Kung maalala nyo itong discussion natin from the previous meeting. Okay? So, your functional block diagram is something like this. Okay? In which you would be determining what is your input. Okay? What is your input transducer? What is your controller? What is your error or activating signal? What is your process or plant? Okay, what is your output? Okay, what is your transducer? Sensor, I mean. Okay, and some other things, like for example, what are the disturbances involved? So this is what you call the functional block diagram. Okay, papalitan nyo lang to ng mga particulars. Ito, yan, papalitan nyo lang yan kung ano yung applicable dun sa system nyo. Pero basically, we would use this as parang general architecture of your system. Ita-translate lang natin ito dun sa dun sa particular system niyo by determining what are the things or what are the components that actually applies into your system. And that would be your functional block diagram. Okay, is that understood? Okay. Sige. But the functional block diagram may not actually help you at all. Okay. It would actually lay out it would actually try to it would parang bibigyan niya kayo ng understanding, ng fundamental understanding of how your system works. Okay. Through this functional block diagram. But in order for you to implement that system, you need what we call Okay, what we call a schematic. Kasi ito yung practical implementation. Okay, the functional block diagram is that implementation of your system. Your system is to be implemented in a schematic. Okay, so yung schematic ang pag-uusapan natin when it comes to having your system to be implemented in the actual application. Okay, so it also means that some of this for example, some of this some of these things are not actually or actually is something that is translated into a certain component. Okay, kasi yung iba diyan konsepto lang. Okay, which means hindi naman siya tangible na na equipment or na component. For example, this summing junction at saka yung summing junction na to. Okay, basically those summing junctions are not real life components. Hindi nyo makikita yan dun sa actual na schematic. Okay, it just shows that there is an additive disturbance, okay, in your controller, in the form, say for example, ng white noise. Okay, because basically white noise is something that enters or goes into your controller. Okay, it goes into your controller. So therefore, hindi kayo makakita ng physical na summing junction dun sa loob ng controller ninyo. So basically, itong summing junction to, tsaka itong summing junction to are just concepts. Okay? Which is not the same as this summing junction. Because basically, itong summing junction na to actually involves, it actually involves a physical component. Merong physical component na involved dyan. Okay? For example, yan, together with your controller, okay, yung summing junction na yan, together with your controller, actually is represented in a schematic as an op-amp circuit. Okay, specifically, yun yung tawag nating adding or summing amplifier. Napag-aralan niyo ba to? Sa electronics, electronics courses niyo before? Anyone? Ay, may nakalala ng isa. Okay, so I hope nagdaanan nyo ito summing amplifier na to. Because basically, what your summing amplifier does is that it adds up. Okay, it adds up signals. Okay, into your op-amp. So you use the op-amp to actually add signals. Okay, so in this case, ayun. What we need to do here is to add two signals. Although yung isa, bibigyan natin ng negative, kumbaga iyan natin siya, i-invert natin yung cycle niya. Basically because we need to actually these two to subtract each other. Okay? So, we can actually do this thing, okay, this operation in a very basic manner using a summing amplifier. Okay? And a summing amplifier is an op-amp circuit. Ngayon, yung controller ninyo can also be implemented by the same op-amp. Okay, dagdagan nyo lang ng for example, ng capacitor. Okay. This now can be used as a controller. So, basically, sa schematic niyo lalabas itong summing junction at saka yung controller niyo are basically the same component or the same circuit. Okay? So, Again, yung nakikita nyo dito is a physical, is a functional block diagram. This is a functional block diagram in which some of this can actually translate to something into 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 physical components na makikita nyo rin sa schematic niyo. Pero yung iba dyan, hindi. Okay? Is that clear? So I hope this is quite clear or nagkakaroon kayo ng konting idea. Okay. Kahit pa paano, nagkakaroon kayo ng konting idea on how these things actually translate into actual. Kasi we may be discussing in this case, we may be talking about theory. Okay. Pero merong mga mga implications yan. Okay, in terms of how we actually implement this into schematic. Okay, sandali lang ulit . Okay, so ayun. So again, it would kahit na sabihin natin na ito nasa theory lang ito. Okay, or this is in theory. Okay. Meron mga implications yan when we actually translate that into schematic. Okay? So, in that case, after you have if you have obtained the schematic, saglit lang . Okay, so after you have you were able to obtain a schematic. Okay, you now proceed to convert that schematic into obtaining a block diagram, a signal flow diagram, or a state space representation. Okay, and although that may seem as something like block diagram, so ibig sabihin visual siya. Okay, kasi block diagram siya . Okay, signal flow diagram siya. So it's a diagram. So again, it's visualization. Okay. Sus lang. Mahirap magsalita ng tuloy-tuloy ng 6 hours. Okay. So makikita nyo parang ang sinasabi niya dito is that you convert it into a visual aid, okay, or visualization. Actually, itong mga to also comes up with what we call mathematical models. Okay? Which means although there is, for example, a block diagram siya. Okay? Ang makikita nyo na sa block diagram na yan are not components. But actually, what function, okay, do this, how do we describe these components in terms of mathematical functions? Okay? So, doon na lalabas yung tinatawag nating mathematical model. Okay? So, yun yung part na sinasabi ko na even though these are visual aids or visualization of the model. Okay, these models actually go with some mathematical models. Okay, they go with mathematical models na meron siya. Okay, so step 4 actually is one of the critical parts of our part of our course kasi ito na yung part that we translate this schematic into mathematical model. And this is actually covered in this topic. So dito sa topic 2, okay, we would cover how we would be able to come up with a mathematical model, okay, for your system. Okay. Number 1, we will discuss what are the approaches available for us to do or to obtain mathematical models of systems. Okay. And we would be discussing to answer that yung approaches, okay, we would be discussing 2. Okay. Pero we would be for this course, we would be entirely using one of those 2. Okay, kasi yung number 2 kasi, mamaya papaliwanag ko. Pero basically, medyo marami pa tayong kailangan mathematical tools para magamit natin siya in extensively. Okay. And in our case, since we are just studying control systems engineering in a not so in a very basic level. So bali entry level natin ito sa control systems engineering. Okay. We would be discussing yung basic way of modeling your system. Okay, which is yung what tatawag natin later on, transfer function approach. Okay. So yun yung step 4 na i-discuss natin. Okay. Now, that is for this this topic 2. Okay. Yung topic 2 and topic 3 actually covers yung step 4. Okay. Now, you can imagine now that your system, okay, kasi yung pagbabasihan din natin yung pagbabasihan natin ng pagkuha ng block diagram is basically based on the functional block diagram. So you can imagine this, ang dami na nakasulot dito, pasensya na. Pero you can imagine this, dito natin siya kunin. Topic 1. Ayan. Ito. Basically, you can imagine this, at saka this. Meron kayong, instead na makikita nyo na yan ay components, ang makikita nyo sa loob niyan ay mga models. Okay? Or mathematical models yung makikita nyo sa loob ng mga block diagrams na yan. O ng mga blocks na yan, I mean. This is the block diagram. Ito lang yung block. Okay? So, doon sa loob ng mga blocks na yan, ang makikita nyo basically are mathematical models instead of the component name. Okay? Instead of seeing the component names inside these blocks, you can imagine them to contain block diagram, mathematical models, expressions, basically mathematical expression. Okay, na visualize yun ba? Okay. So, ang gagawin natin dun sa part na yun is, ang gagawin natin sa part na yun is, since there are many blocks involved, in step 5, what we will do is we will reduce those blocks into a single block or into a closed loop system. So, again, imagine niyo na ganito siya, marami siyang blocks. Okay. Gagawin natin yan, ganito lang. Either isang block na lang siya. Okay. O kaya, isang block siya, pero merong feedback. Okay. So, yan. That is step 5. So, either we will reduce this many blocks into this one, into this, or into this. Okay. Is that understood? Okay. Now, in step 6, after that, we were able to reduce it into a single block or in this one. Okay. We will now analyze, design, and test. Okay. If the physical system is available, o kaya, instead of actually testing it in the physical, we will use simulation. Okay. In order for us to test the system. Dito natin determine yung mga parameters niya, and if we are meeting certain requirements, and if the analysis shows that the requirements are not yet met, Okay? If the analysis shows that the requirements are not yet met, okay, by the system, then we have to design the system so that the requirements are to be met. Okay? And then we will verify those design using simulation or kaya testing if we have the physical system. Okay? So those are the process. But remember this. This process is not at all linear. Okay, when you say when you say the process is linear, it means that you perform step 1, step 2, step 3, step 4, step 5, step 6. Linear siya. Okay? But this process is not at all linear. Okay? So, depende yan sa case niyo. Minsan, nasa step 3 kayo, step 4, pupunta kayo ng step 6. Okay. Minsan, nasa step 6 kayo, kailangan nyo bumalik ng step 2. Kasi may mga corrections kayo kailangan gawin. And then, step 2, babalik kayo ng step 3. Then, step 4. Okay? So, kumbaga, hindi to straightforward na laging isang direction lang siya. Okay? It may involve iteration. Okay? And it also may involve alternatives. Okay? For example, after ng step 4, maaaring after ng step 8, okay, since ang problema ninyo is that masyadong komplikado, your system is too much complicated for you to obtain models, okay, you might resort to an alternative path after ng step 8. Okay, that is, you use a computer application in order for you to obtain mathematical model or mathematical models for your system. Meron kasing ganong applications ngayon. MATLAB has one of those applications. That is, meron kayong physical system. Andyan na yung physical system. What you would do is, you would try to obtain a mathematical model using yung testing results galing sa system niyo. So what you would do is, yung physical system niyo, no? So yung physical system is already there. Magbibigay kayo ng test input signal sa system niyo, and then you would obtain the output. Now, that test signal at saka yung output niyo are fed into the computer application, and then your computer application would then return what is the best model that would describe the system based on the input-output signals that you fed into your application. Okay? Na-gets nyo yun? Yung logic doon. So, mukhang hindi. Ayun. Ganito. Basta meron na kayong physical system. Okay. Tapos, since hindi natin siya ma-model ng conventional modeling, okay. Kasi pag sinabi yung modeling, ano yan eh, magde-derive talaga tayo ng mga equations. Okay. Hindi masyadong komplikado para sa inyo yung system para mag-derive ng ganung mga komplikadong. Okay. An alternative is, gamitan natin siya ng computer program or computer application in order for you to obtain the model based on the actual input or actual output signal given na meron kayong input. So, you can imagine this to be something like, para meron kayong, ito yung system niyo, magbigay kayo ng certain input 1. Okay, tapos mag-produce siya ng output 1. And then, input 2. Then, output 2. I-show nyo yung output based dito sa input na to. Okay. Now, what you would do is itong input-output pairs na to, yung input-output pairs na yan, ilalagay natin yan sa isang computer application. Example, MATLAB. Okay. Now, this computer application would then return, okay, it would then give you a mathematical model based on what the input-output signals were able to you were able to feed into this computer application. Okay, so that's one way of obtaining mathematical model. Okay, so yung gagawin kasi natin dito sa course natin is magsisimula talaga tayo sa schematic. Okay, schematic, and then from the schematic, you will obtain the model. So medyo ano to, medyo theory talaga yung gagawin natin dito sa lecture. Okay. Pero again, in practice, okay, in actual practice, instead of actually trying to um, obtain the mathematical model using the schematic, okay, and you see that the schematic is too much complicated, is very complicated, very much complicated for you to actually analyze it para makakuha ka lang ng model. Baka mas maganda, gamitin na lang natin siya ng computer-based approach. Okay, so that's an alternative for us to do. Okay, so meron ganong capability yung MATLAB natin. Okay, it's just that I don't think magagawa natin siya sa laboratory. Okay, for now. Kasi una-una wala tayong physical system that we can obtain data from. That's a problem kasi wala tayong physical system that we would be getting our data from. Kasi this requires data kasi galing sa isang actual physical system. Okay? So, naiintindihan ba yan? Okay, so sige. Let's proceed, no? So in terms of modeling, okay. So sinabi na nga natin yung step 4 as the modeling part. In terms of modeling, we have two methods. Okay. We have two methods by which we can actually obtain the model. The third one being actually tatlo siya. The third one being the computer-based approach as I discussed earlier. Okay. Pero there are two methods that we will discuss here. Number one is we can obtain the models or we can express the models using transfer functions. Okay, in frequency domain. Okay, and number two, we can have the models as state equations in time domain. Okay. Now, whether you use approach 1 or method 1 and method 2, whether you use this approach or this approach, okay, when modeling systems from scratch, okay, and using analytic methods, you should be able to know ano yung fundamental laws or fundamental physical laws that applies to each case. Okay? For example, if you are modeling electrical networks, you should be able to apply Ohm's law and Kirchhoff's law because those are the basic physical laws that apply to electrical networks. For mechanical systems, you should be able to apply Newton's laws of motion. Okay? Yung first law, second law, tsaka third law. Babalikan natin yun in a later topic kasi we will be modeling mechanical systems. Okay? So, may marami pang system. For example, pneumatic systems, you should be able to use physical laws that apply to pneumatic systems or hydraulic systems. Dapat meron tayong may knowledge tayo ng tinatawag na fluid mechanics. Okay, which in our case, wala naman tayong knowledge ng fluid mechanics, so this will not apply to us. Okay? So ayan. So so ayun. But in our case, we will be discussing electrical networks, mechanical networks, at saka electromechanical systems. Okay, so yun yung pag-uusapan natin in the next topics. In topic 2, that covers electrical systems. In topic 3, I think mechanical and electromechanical systems tayo. Okay? So yun. So um, so our system, okay, remember that ito yung ano natin, ito yung pag-uusapan natin na madalas. Okay. So, um, yung ating system, okay, is basically represented by a block diagram, something like this one. Okay? Sige lang. Ang bilis matayo ng ano ko, lalamunan ko. Okay. So, yung system natin is basically represented by a block. Tapos meron tayong input signal at saka yung output signal. Okay, normally, we would use the notation R of T for our input signal. And para maalala nyo na ito ay R. Okay, because R would stand for reference input or reference signal. Okay. And then yung output natin is represented using is represented by the notation C of T. C as a function of T. Okay? So basically yung R is a signal that is a function in time domain. Okay? Same thing with C. C is also a signal that is a function in time. Okay? So C here is stands for, yung C dito stands for control variable. So, you associate now reference with input and control variable with output. Para maalala nyo na yung R of T ay nasa input side, tapos yung C of T is nasa output side. Okay. Now, using this signals, R of T at C of T. Okay. Our system is described using a differential equation. Okay. So, para ma-relate natin, so that we can relate C of T with R of T. Okay. The relationship between R of T and C of T para ma-describe natin yung system natin. Okay. Is that these two are related by differential equation. Okay. So, R of T and C of T are related by differential equations. And for us to be able to see how that differential equation looks like, ito siya. Yan. Yan yung itsura ng differential equations. Or differential equation that relates C and R. Okay? Is that clear? Okay, class, sandali lang kukuha ako ng water. Okay, sandali lang. Baka bigyan nyo lang mga 3 to 5 minutes. Okay, sandali lang Hello, class?
Hello po, sir.
Wait lang. Nag-feedback yung ano ko. Ayun. Sige. Wait lang. Bukas kasi yung nasa phone ko, kaya ayun, nag-feedback siya na nag-test ako. Okay. So, asan na ba ako? Ayun. So, as I was telling, dinig ba ako? Okay, dinig ba ako ng lahat? Okay. So, sige. Um, hindi ko siya kita. Okay. Anyway, so as I was saying, yung differential equation that relates this R of t and this C of t is actually of this form. So as you can see, masyado siyang it would be really complicated. Okay? The differential equation that describes the input and the output of the system in terms of the input and the output signals is actually really complicated. Okay? So that is why, instead of actually describing the system in terms of that differential equation, okay, we can just simply use either the transfer function, okay, or the state equations, okay, in order for us to describe these two systems, or this system using these methods, okay, and it would be much more simpler, okay. For one thing, ang isang mapapansin natin that for example, when we use transfer function in order for you to describe the system, is that instead of actually describing the system in terms of this differential equation, mare-reduce natin yung description sa ganito. Okay? Um, we can describe this instead of, parang gano'n muna kasi. Una, instead of having R of t here, we will have R of s. And R of s is the Laplace transform of R of t. So take note of that. R of s is the Laplace transform of R of t. Okay? And then we also have here C of s as the Laplace transform of C of t. Okay? Now, if you now have R of s and C of s, meaning makukuha na natin yung Laplace transform ng ating input at saka ng ating output, then we can describe the system, okay? We can describe the system, okay, using using the notation G of s, which is now what we call the transfer function. Okay, so the transfer function relates the input and the output of your system. Oh, sorry, the output of your system to its input in terms of Laplace transform. Okay, so that's how we define the transfer function. Transfer function is the relationship between the output of the system to its input using Laplace transform. Okay. Now, I know that one of the requirements or one of the prerequisite of this course is the advanced math or advanced engineering mathematics. Tama ba? Tama, di ba? Okay. And now, at this point, I'd assume na naaral nyo na o napag-aralan nyo na yung Laplace transform sa advanced math ninyo. Tama ba ako? Okay. So, at this point, At this point, I am expecting that you have a working knowledge of the Laplace transform. And although, one of our lessons, okay, palamang sa next meeting, is to actually review your Laplace transform. Pero I won't really dwell for too long into this lesson. Kasi number one, ang expectation ko is that you do now have the working knowledge, okay, of the Laplace transform at this point. Okay? Yun yung isa sa mga expectation ko. That's number one. Okay, and number two, we would not be really using the Laplace transform as kung paano nyo siya ginagawa noon sa advanced math ninyo. Okay? Since ang assumption nga is that you already have this working knowledge of the Laplace transform already at this point. Okay? It would be expected of you na sana magagamit natin siya in a manner na hindi naman talaga katulad ng ginagawa natin sa advanced math before. Okay? So medyo mas advanced naman yung gamit natin. Pero if you would remember, isa sa mga objectives or isa sa mga magandang benefit that we were able to get from your Laplace transform is that it actually converted or it actually made operations that requires the use of calculus, okay, into operations that are reduced to algebraic equations or algebraic operations. Kumbaga, instead of magka-calculus tayo, magde-derivative tayo, mag-integrate tayo, instead, these operations can actually be performed using multiplications and divisions instead. Okay? Yun yung isa sa mga advantage of using the Laplace transform. Especially when we are dealing with differential equations. Okay? So, yun yung gagawin natin actually. Once na ma-establish natin na ang pinakagamit talaga ng Laplace transform sa atin is we actually would want to have our equations or our operations using derivatives and integrations be reduced to operations in multiplications and divisions. Yun na yung gagamitin natin in the future lesson. So that is why I would not really dwell on this lesson, this part. Okay. Magre-review tayo ng konti pero hindi ganoon ka tagal yung i-spend nating time in the review. Pero again, I am expecting that you have this working knowledge already of the Laplace transform. Okay? So if you don't have this kind of working knowledge pa, okay, you might want to go to review, okay, or you might want to study ahead of me discussing this part. Okay? So yun. Now since this G of S, itong G of S ngayon is now what we call the transfer function. Okay? And that relates now your R of S and C of S. Basically, yung relationship na yan is basically, again, sasabihin ko nga sa inyo, algebraic na siya. Instead of actually having this kind of relationship which contains higher order derivatives. Okay? Yung inyong relationship na to will actually be reduced into this form. C of S equals R of S times G of S. Good. Instead of actually using this differential equation in order for you to analyze this kind of system, magiging ganito na lang yung working equation natin. Okay, but of course, remember na ito ay mga variables na nasa time domain and ito ay mga variables na nasa or mga functions na nasa S domain. So therefore, if you want to look for the output C of t, okay, we still have to find the inverse Laplace transform from C of S into C of t. So that is why kailangan nyo talaga ng working knowledge on the Laplace transform and the inverse Laplace transform. Okay, is that clear? Okay. Now, the major advantage of using this type of modeling, okay, yung major advantage ito is that they rapidly provide stability and transient response information. It means, given na meron kayong G of S, okay, from the G of S itself, with minimal computations, you would be able to determine whether the system is stable or not, and you would be able to obtain some transient response information with minimal computations. Konting computations lang, makukuha na natin itong information na to. So that is how intuitive. Ang major advantage ng frequency domain modeling is intuition. Okay. The modeling approach or the resulting transfer function is very intuitive in terms of stability and transient response information. Madali siyang makuha, okay, with very minimal computations. Okay. The disadvantage of which is its limited applicability. Okay. There are restrictions or there are certain things about the system that needs to be satisfied, okay, para ma-apply natin yung frequency domain approach. Okay. Although many systems would actually fall into those restrictions. Ibig sabihin, marami naman tayong mga systems na talagang papasok naman dun sa tinatawag nating restrictions. Still, there are many more systems that are not within those restrictions and are therefore cannot be modeled using the frequency domain approach. Okay? Especially yung mga bagong systems na lumalabas ngayon. Yung mga bagong systems that are widely used in modern things or modern yung mga ngayon, yung mga ginagamit ngayon. Maraming mga doon, marami sa mga systems na yun are not within the restrictions that are at which the frequency domain approach applies to. Okay? So number one is dapat, ito yung mga restrictions. Dapat yung system ninyo ay linear, okay, time invariant, okay, or can be approximated, or there is a certain range of operation that they are linear and time invariant. If your system is non-linear, or your system is time varying, or both, okay, your system cannot be modeled using frequency domain approach. Okay, again, there are still many systems that are linear and time invariant. Okay, but there are modern systems, yung mga systems that are used for today for solving today's problems. Okay, that are not linear and or time varying. And for those cases, the time domain approach, okay, can be used. Okay, isa pang hindi pwedeng applyan ng naalala ko pala. Isa pang hindi pwedeng applyan ng frequency domain model is yung tinatawag ng multiple input, multiple output system. Okay? Frequency domain approach can be applied very easily to systems that have single input and single output system. Okay? Pero, kapag ang system mo has multiple inputs and multiple outputs, still, you can, assuming that the system is linear and time invariant, okay, you can still apply, transfer function to model this one. Ang problema lang is that the complexity increases variably. Tataas bigla yung complexity nito. Okay, for example lang this is a single input, single output system. In order for you to have a model for this one, you can use a single model to describe this system. Single input at single output. Pero, doblehin natin yung input at saka output. Okay? For you to be able to completely describe this system, kailangan mo ng 4 na transfer function. Paano naging 4? Isa para dito. Okay? Halimbawa, ito ay R1, ito ay R2, C1, tsaka C2. So, isang transfer function para sa R1, C1 na pair ng input-output. Isa para sa R1, C2 na pair ng input-output. Isa para sa R2, C1, at isa para sa C2, sa R2, C2. So, in that case, you need 4. Okay, you need 4 transfer functions in order for you to completely describe the system. Okay? So the complexity of your computations increases dramatically kapag nagkaroon ka ng multiple inputs at saka multiple outputs. So for a single input, single output system, isang transfer function lang ang kailangan mo. This time, for a 2 inputs, 2 output system, kailangan mo na ng 4. Okay? So that is one thing na medyo mahirap i-apply ang transfer function model o transfer function approach. Okay? Is that clear? Okay. Yung time domain approach. Okay, sige, pababa na. Yung time domain approach is can be used to model anything, basically anything. It can be used to model non-linear or linear systems. It can be used to model time varying or time invariant system. Okay. It can also use to model multiple inputs or n inputs it can be used to model n inputs and m outputs system, whether it's a single input single output system or marami talaga. Okay, and it can conveniently describe the model in a single compact expression. All it requires are 4 matrices. Kailangan lang niya ng 4 na matrices, A, B, C, D. Okay? Kaya lang, again, these are matrices. Okay? So, the mathematical approach, or this mathematical approach, actually requires more complex mathematical tools, such as the tools of linear algebra. Okay? And, although pinag-aralan din sana ninyo ang linear algebra sa advanced math ninyo. Okay? But this time, hindi ko siya ihingin sa inyo as a skill. Okay? Kasi, again, we're studying control systems engineering in a very, in an elementary manner, or in an elementary level. Okay, medyo mababa pang level yung, kumbaga entry level pa lang kasi tayo in terms of studying your control systems engineering. So therefore, we would like to have our study to be as as simple as possible. Okay, yung medyo simple lang naman siya. Hindi yung ibubulaga tayo ng sobrang mathematics. Okay, and kumbaga, dahan-dahan lang. So, we will concentrate more on the transfer function approach. Okay. So, although bibigyan ko kayo ng material, or possibly baka bigyan ko kayo ng konting material in terms of state space approach, okay, or time domain approach. Dahil kailangan naman natin siya sa laboratory, if if you are taking the laboratory course, kailangan natin siya medyo maaral para sa laboratory course natin. Okay. But still, sa ating lecture course, more or less mas magko-concentrate tayo sa sa transfer function approach. Okay? Is that clear? Okay. So, I think I can stop right there. Kasi yung kabilang section nandito pa lang din. So, para medyo pareho lang din kayo ng inaaral. Okay. So, I think I can stop at this point. Okay. And we will continue this on next meeting. Okay. So, next meeting we will review your Laplace transform. You will review your Laplace transform. And we will study transfer functions. Okay? So, makikita nyo naman nandito na yan sa no? Nandito na yan sa inyong content library. Okay, so ito yung whiteboard niyo. Nandito yung mga sinusulat ko. So, you can obtain your own copies of this doodles that I made. Yung mga notes na ginawa ko dito. Pwede kayong kumuha ng sarili niyong copy. Okay, in order for you to study them. Okay. And later on, yung recording nung natin, nung ating session will be posted also. Okay? So, and in fact, pwede naman yung hindi hintayin na ma-post siya. I think this is available sa stream. Bali pagkatapos ito, may malalabas na link papunta sa Microsoft Stream. Makukuha niyo naman siya. So, pwede niyo siyang kunin from there. Okay? So, ayun. May questions ba? Yes, si Mr. Baramante.
Ayun sir, regarding lang po sa activity sa lab, pwede po ba sir?
Actually nabasa ko yung message mo.
Ayun sir, about po do kasi hanggang ngayon po kasi sir wala po ata, hindi pa rin po na-update yung
Ano yung naging problema doon? Wait lang
Ano po ata sir, kulang po ata yung sa mga program listing. At saka wala, di ba may exercise po na nakalagay? Blanco po yung akin. Bali, ang nakalagay lang po doon is program listing 3 lang po.
Ito ba yung sinasabi mo? Wala yung ibang program listing?
Opo sir, yun po.
Ang ko kasi sana is kayo sana yung gagawa ng table.
Okay po sir.
Kumbaga, may program listing 5. Gagawan siya ng table ng program listing 5. Ganun yung mangyayari. Kumbaga, binigyan ko lang kayo ng example dun sa una. Binigyan ko lang kayo ng example dun sa unang part. Pero ang ko sana is kayo na yung gagawa sana nung mga table. So parang ang binigay ko sa inyo. Tapos kayo na magtutuloy nun. Okay lang.
Okay po.
Okay. So,
kala ko po kasi kulang. Thank you po.
Ayan, sige. So, okay lang. Sige. So, bukod doon, may question pa ba? Mababago lahat ng mga deadlines niyo tsaka yung mga quizzes natin. So, yung quiz number 2 is, yung quiz number 1 nyo is to be announced pa. So, isa sa mga pinag-iisipan ko is, instead of having quiz number 1, 2, 3, and 4, gagawin na natin siyang quiz 1, 2, and 3. Okay, pareho lang naman din kasi yun. Kaya lang, problema lang kasi sa quiz 1, 2, and 3. Yung scope kasi nung quiz number 1, medyo dadami ng konti. Okay. I mean, kung ano yung matatapos natin until umabot yung schedule ng quiz number 1. So, that's one thing that I'm thinking about. Pero, give me 1 week to decide on that. Kasi titingnan ko rin kung ano yung mas sa inyo. Ang sa akin kasi, mas prefer ko talaga is, mas konti sana yung assessment. Mas konti yung assessment, pero mas, kumbaga, hindi ganun karami yung assessment na ibibigay natin. Kasi nga, ang ayoko nga kasi is, mas stress kayo, for example, sa dami ng assessment natin, alam niyo yun, parang ma-pressure kayo na magpasa ng ganito, magpasa ng ganyan. So, as much as possible, kukuntian natin siya. So, in this case, titignan ko nga na quiz 1, 2, and 3, tapos final exams. Pero meron naman kayong mga assignments. So yung assignments niyo, doon ako babawi ng grading. Okay? Yes, Miss Jose?
Sir, yung sa homework po ngayon, pwede pong late magpasa.
Okay lang. Sabi ko nga sa inyo, merong merong parang tawag ito, parang soft due date tsaka hard na due date. So, again, yung deadline niyo ng homework 1, definitely mababago yun. Hindi ko pa lang siya binabago kasi pinag-aaralan ko pa kung kailan ko siya, kung ano yung mga bagong mga dates. So that is why, Pero sa ngayon, kung ano yung nakalagay na date doon, siguradong hindi masusunod yun. So, halimbawa lang na mag-lapse yung deadline, okay lang naman yun. Wala naman lang magiging kaso doon. Hindi naman ako na pagdating sa homework hindi ako nagde-deduct when it comes to late submission ng homework. Okay lang naman sa akin na late yung submission ng homework, late submission yung homework. Kahit sa laboratory nyo, yung activities, kahit ma-late siya, hindi naman ako nagde-deduct kasi activity siya. Ang medyo lang ako sa deadline is yung assessment. Yung quizzes, yung major exam, yun yung medyo sensitive ako sa deadline. Pero pagdating sa mga homework tsaka hindi naman masyadong kaya lang, meron lang talagang date na talagang hindi na kayo pwede magpasa ng homework. After that date, hindi na kayo pwede magpasa ng homework. Okay? So, sa ngayon, wala pa naman yung date na yun.
Okay po, sir. Thank you po.
Si Mr. Tingley, may question ba siya?
Wala na po, sir.
Okay. So, sige. Let us dismiss na for tonight. Kasi alam ko gutom na rin kayo. 7 to 9 naman kasi yung klase natin. Okay, so I'll see you on Tsaka ito pala prepare for the possibility na baka magkaroon tayo ng online session sa Sunday. Kasi sa Sunday yun yung sinasabi ko sa inyo last time na merong makeup class. Okay. Para dun sa mga halimbawa, nung nakaraang Sunday, that's Monday, Thursday class. Okay. So, ngayong Sunday, yung Tuesday, Friday class naman. So, I am thinking na baka para makahabol tayo ng konti. Baka mag-meet tayo sa Sunday. Pero baka pa yun So, baka pwede rin naman na asynchronous na. Okay. So, ayun. Titingnan pa natin kung ano yung natin. Pero mag-prepare din kayo just in case. Kung hindi naman kayo makakain sa Sunday, okay lang din naman. Wala namang kaso. Hindi naman siya masyadong big deal. Again, recorded naman lahat ng online session. So, may pagkakataon naman kayo na balikan siya. Okay? So, sige. Let us dismiss na for tonight. Okay? I'll see you on Friday.
Thank you, sir.
Thanks, Ted.
Thank you, sir.
Okay. Palagaw na lang Thank you.